All right, let's go ahead and get started with the video for Monday night's homework. You'll have to excuse me, I'm using Mr. Bishop's setup, and so there may be some small technical difficulties with his markers. I'm going to assume you've read the question. If you haven't read the question, hit pause on the video, grab your handout, or look at the screen and go ahead and read it. Also, as a reminder, anything in black are things you should write, things that I would want you to have as part of your solution. And anything I write in blue is just notes, things that I'm going to say kind of on the side, discussing kind of the background mathematics or theory for each of the questions. Okay, let's knock out A. A is 1. Let's go right to the black that you should be able to quickly answer. The answer is x equals 6. Right, that's the location or the value of x for which there's a local minimum. And the reason, oops. All right, not sure why it's not erasing, but the reason is f prime changes sign. Negative to positive. And I really do want you to write it out like this. If you use a minus symbol and a plus symbol, you're probably okay. But what I do not want you doing, let's go to the red, is just saying things like 6 plus minus. This stinks. Do not do this. This is so lazy. Please write out x equals 6 and write out using kind of words the reason, right? It's a reason. It's a words thing. So that's A. Let's go ahead and clear the screen and redraw our space as best we can using, like I said, limited resources. So while I'm doing that, let me just go ahead and narrate. The reason tonight's video is particularly important is for question B. Finding absolute value is something we didn't probably do enough practice on this year. I don't think there's anything about the mathematics that's going to be new, right? This is not going to be a new idea. But just kind of what's required for full credit is something I'm not 100% positive you guys know. So let's go ahead and do the absolute minimum value. So we've already identified a location for a local minimum, and that location was x equals 6. What we have to do is find the minimum value. So find whatever f of 6 is. And here's how we're going to do that. We know an initial condition, or actually what I would really say is we know an f of b. So what we need to find is an f of a, and we're going to use fundamental theorem of calculus part 2. F of 6, well, I tell you what, let's kind of go to the blue first. So here's the theory behind what we're going to do. The theory behind what we're going to do is say that the integral from 6 to 8 of f prime of x equals f of 8 minus f of 6. Right. This is FTOC part 2 where we're using prime as what we're integrating. And so just regular f is the appropriate notation for antiderivative. What we are going to do is rearrange this equation so that it solves for f of 6. So it's going to come out like the following. F of 6 is f of 8 minus the integral from 6 to 8 f prime of x dx. So if we look, right, we know that f of 8 equals 4. And so all we need to do is figure out what the integral of this graph is from 6 to 8. Now take a look. We've got the areas broken down for us. This is 1, 2, 3, 4, 5, 6. 7, 8. So this section has an area of 7, and it's above the axis, so it counts as positive. So we would say that f of 6 is 4 minus 7. F of 6 is negative 3. So we have found f of 6, or we have found the value at that local minimum. I apologize for all the kind of dots that are appearing on my screen. It's actually an issue with Mr. Bishop's projector and his sensor inside of his projector. I'm going to clear the screen real quick, but make sure you have this down on the page. We are not done, though. what we have found is a local or relative minimum value. We have not necessarily shown that it is the absolute minimum. The other potential absolute minimums are either the endpoints on the left or the endpoints on the right. So what we're going to do now is check the values of the endpoints and see how those come out. What we have to do is see if f of 0 and f of 8 are greater than or less than. First, let's do f of 0. So now 0 is kind of a beginning value and 8 is an ending value. So we're going to say, okay, f of 0 equals f of 8 minus the integral from 0 to 8 f prime of x dx. So it's the same thing where we're solving for one value of f using another value of f and the integral of f prime. We're rearranging, sorry, this should be blue, but we're rearranging FTOC part 2. And remember, this is blue, so this was notes. You wouldn't write that on the page. So let's figure out what f of 8 is, and I'm pretty sure f of 8 is still 4. So let's figure out what the integral from 0 to 8 is. So we have 2 plus 6 minus 3 plus 7. So we have positive areas of 6, 7, and 2, which gives us a positive total of 15. And then we have an area below that's 3. So it's a total of 12. And here's what we discover. We get negative 8. F of 0, all right, now it's really acting up. F of 0 is negative 8. F of 0 is lower than f of 6. So f of 6 is not the absolute minimum. It's just a relative minimum. F of 0 is lower. Remember, that's not a prime right there. That's just parentheses. The last thing we're going to check is f of 8. And now it's pretty obvious that since we know f of 6 and we're going to add on all of this area to find f, oh, I'm sorry, never mind. Here's what we know. F of 8 is our other endpoint. So we know f of 0 is negative 8. We know that f of 6, which is the local minimum, if memory serves, was negative 3. And then we know f of 8 already. It's given to us. We know f of 8 is 4. And so what we would say here in conclusion, we would probably write a concluding statement, something like f of 0 equal negative 8 is the absolute minimum. And I'm going to abbreviate, but only because my pen is giving me fits. It's the abs min. It's the absolute minimum. I would probably spell that out if you weren't having technical difficulties. Okay, let's knock out C, which is going to be pretty easy. C is something we practiced a lot last week. So much like A, I would want C to kind of go quickly and correctly. It does take a little more kind of thinking, but not too much more. All right. We have to determine the intervals on which f is concave down and increasing. So let's just write out a couple of statements. If f is increasing, f prime is positive. If f is concave down, that means that f double prime is negative, or in this case, if f double prime is negative, f prime was decreasing, right? If f double prime is negative, that means the graph above it, right, f prime is a decreasing function. So that's what we're looking for. We're looking for f prime positive, but f prime decreasing. And that's going to be pretty easy to identify. It's positive, kind of all of this, and then it's decreasing 0 to 1, 3 to 4, and that's it, right? Those are the only times where it's both above the axis and decreasing. So our answer is going to be on the interval 0 less than x less than 1, comma 3 less than x less than 4. And our justification is just that f prime is both positive and decreasing. Please don't say it, right? We never say it is positive. We never say it is decreasing. We use whatever noun is. So once again, my pen is giving me fits. So I'm going to try to get the at least DEC in here. All right, I was having a lot of trouble writing in the space down here. So it's both positive and decreasing. All right, I know I didn't do a very good job of squeezing that word in, and I apologize. All right, the last thing we need to do is D. D is what I call a leap of faith problem. A problem that at first kind of looks a little disorienting, and you look at it, and your first reaction is like, ugh, no, I don't want to do this. But it's actually, if you just kind of work through it, not really that scary. We're given a function, and we're asked to find the slope of the line tangent to that function at a specific location. So in other words, this question is just basically asking us to find g prime of 3. That's all it is. Given g of x, find g prime of 3. Don't make it harder than it needs to be. Okay, and then we just ask ourselves, okay, if we need the derivative and we look at the type of function that we have, what's the appropriate differentiation technique? It's not product rule, it's not quotient rule, it's just the chain rule. So let's go ahead and apply our chain rule. So first let's identify g prime of x. So the derivative of something cubed is 3 something squared. And then you need to chain on something prime. Well, if something is f, then gosh darn it, something prime is f prime of x. Now we need to find g of 3, and this is where we're going to do it for real. Sorry about the pen kind of being haunted. It has a mind of its own. So g prime of 3, that's going to be 3 f of 3 squared times f prime of 3. Well, let's take a look. We know, hey, they gave us, oh, come on, pen. They gave us f of 3, so we know it's negative 5 over 2 squared. And f prime of 3 is something we can look up in the picture. This is our f prime graph. F prime of 3 is 4. All we need to do now is just multiply this out correctly. So remember, when you have a fraction that you're squaring, you square both the numerator and the denominator. So this is 3/25 over 4. Remember, negative squared is positive. Times 4. All right, that's going to simplify out, and the result should be 75. And I think that's correct. Let me just kind of double check looking at this one to make sure I feel good about it. So we applied our chain rule, we substituted in 3, then we substituted in f of 3 and also 4, squared the fraction, we had a common factor of 4, 3 times 25. Yeah, this seems pretty good. All right, thanks for watching the video. It came in just under 14 minutes. And like I said, B, this question was all about B. To do an absolute minimum, you have to both find the values of the relative minimums, but then also test the endpoints to see which is lower. All right, thank you.